Hello everyone, this is day 5 of our 10 days AWS Masterclass. So in this session or in this episode, we will talk about AWS VPC or AWS Virtual Private Cloud. So in this session, we will do two hands-on projects. So the first hands-on project will be creating a custom VPC. Then after creating the custom VPC, the second hands-on project will be deploying a simple web server in that custom VPC. So before doing the hands-on, as always, we have to talk or we have to discuss basic concepts of AWS. So let's do that. So be patient and let's start with the AWS VPC. What's AWS VPC? So basically, AWS VPC or Amazon Virtual Private Cloud is a service that lets you create and manage isolated virtual networks in the AWS cloud. So basically, AWS VPC is an isolated virtual network in the AWS cloud. So this isolated virtual network provides a secure environment for deploying AWS resources like databases or web servers and other resources with a complete control over your network settings. When we say with a complete control over your network settings, we are saying you can specify the IP address ranges, you can uh, divide your whole VPC into subnets. Uh, you can specify route tables. You can put gateways in the VPC and on the subnets and something like that. So basically, AWS VPC is an isolated network in the AWS cloud. So let's elaborate this technical definition using analogy. So imagine you are a mayor of some city, some big city. So let's say you are a shitty dictator in that city or in that giant city. So basically, because you are a dictator, you decide who can enter, where the roads lead, and even what kind of buildings can be built in that city. So Amazon Virtual Private Cloud works similarly in the AWS cloud, like the city keys, like the shitty dictator keys. Basically, AWS VPC allows you to create your own secure, customizable neighborhood for hosting resources like servers and databases. So you can set rules for traffic flow. You can create sections in the network. You can connect to the internet when needed. You can even disconnect your resources from the internet when needed. So basically, you are the dictator in that isolated network. So you have a full control. You can customize the networking settings as needed. So basically, AWS VPC is an isolated network in the AWS cloud. So I believe that is an enough definition, even though it's not that much. So let's see basic use cases of Amazon VPC. So basically, you can use Amazon VPC like, for example, for hosting web applications. You can use this virtual private cloud or this isolated network to configure or to deploy your multi-tier architecture. For example, let's say there is a financial service platform. So basically, this financial service platform uses a multi-tier architecture to separate the user-facing application from the backend processing and the sensitive data storage. So basically, you will deploy your user-facing application in your VPC in the public subnet, your backend processing application in the private subnet. So basically, you can host or you can deploy a multi-tier architecture in VPC. You can also use VPCs for hybrid cloud connectivity and many other use cases. So I believe that was enough for the VPC use cases. So now it is time to deep dive to the core concepts of AWS VPC. Now let's start by discussing what CIDR is. So now let's, as you can see, I'm in my VPC console or in my VPC dashboard. So let's hit the create VPC button. So when you create a VPC, after giving a name for your VPC, it will ask you to specify an IPv4 CIDR block. So what is IPv4 CIDR block? I believe uh, it's clear what IPv4 is. Basically, IPv4 is an Internet Protocol version 4. So it's the fourth version of the Internet Protocol, which is one of the foundational protocols for communication. So it's 32-bit. It's IPv4 is a 32-bit address format. So for example, here there is, it says 10.0.0. So for example, the 10 one, if you change this number to binary format, you will get 8 zeros and ones. So basically, it is this section before the dot, it's 8-bit array. So when you add all these four, it will give you 32-bit, or yeah, it will give you a 32-bit address. So basically, IPv4 is an internet protocol. So that was clear. But what is CIDR block? So CIDR block is a classless interdomain routing. So CIDR, in the context of an AWS VPC or an AWS Virtual Private Cloud, basically it defines the range of IP addresses assigned to the VPC or to your VPC. For example, as you can see here, for example, the IPv4 CIDR block is 10.0.0.0/24. So when you specify like this, basically you are saying, or you are specifying, my block of IP address range is 256. So I only want 256 IP addresses for my isolated network. So let's change this CIDR block address. First it was 24, it was /24. Let's change this, let's change it to 20. As you can see, if you change it to 20, you have 496 IP, or yeah, IP addresses. So let's talk about this format uh, in depth. So as you can see here, the CIDR notation consists of an IP address, basically this part, the 32-bit address, and a prefix. A prefix is after the slash sign. I believe it's visible. So a prefix is after, for example, this 16 is a prefix. So the prefix determines how many IP addresses are available in your isolated network. For example, a smaller prefix number like 16 means more IP addresses. So basically, if you put 16 after the slash, basically you have more IP address available in your VPC. If you put a larger prefix number in your VPC or on your CIDR block, basically it means fewer IP addresses are available in your VPC. Let's see it in practice. For example, if you make this prefix to 24, as you can see here, you only have 256 IP addresses available in your isolated or in your virtual private cloud network. Let's make it smaller. As you can see in 24, it is 256 IP addresses available. If you make it 20, it becomes 4,000. If you make it 16, it will become 65,536 IP addresses available. So I think that is clear. So let's say I believe it's obvious. So if you want in a tabular format, when the prefix size is 16, the number of IP addresses are 65,000. We have talked about it. For example, if the prefix size is 32, you only have one IP, single IP. So basically, CIDR is basically it defines the range of IP addresses assigned to the VPC. It specifies a block of IP addresses that the VPC can use. It can be for subnets, it can be for instances, it can be for other network resources. So CIDR is a range of IP addresses. Now let's talk about subnets. So when we talk about subnets, so a subnet is a range of IP addresses within your VPC. So if you remember, so when we talk about CIDR, we have said CIDR defines the range of IP addresses assigned to the VPC or to the whole VPC. So basically, CIDR is a range of IP addresses or a block of IP addresses that are assigned or that are available to the whole VPC. But a subnet is, as you can see in the definition, a subnet is a range of IP addresses within your VPC. So, because of uh, this nature, because of this nature of subnets allows you to segment your network into a smaller, manageable sections for more efficient and control. Basically, you have specified a CIDR block when you create your VPC. After that, you will divide that CIDR block into subnets or into sections. So that's the idea is the whole available block of IP addresses for your VPC. When you come to the subnet is a range of IP address within that CIDR IP address range. So basically, subnet is a segment of your network or a division of your whole CIDR into a smaller segments. So there are two types of subnets that are supported by AWS VPC. The first one is the public subnet. Basically, the public subnet one is an internet facing. So basically, resources that are deployed in the public subnet resources that are deployed in the public subnets can communicate directly with the internet. So when you come to the private one, resources that are deployed in the private subnet cannot directly access the internet. So resources that are deployed on the public subnet will have access to the internet using internet gateway. So let's say we have said resources that are in the private subnet have no direct access to the internet. We have said that. Let's say you have a backend service or a database, and that database wanted to download patches from the internet. So what shall we do? So when resources in your private subnet wanted to have access to the internet, you will use NAT gateways to give them an access to the public internet. But unlike the public subnets, they don't have a direct communication with the internet. We give them internet access through a service called NAT gateway. Basically, we will put this service NAT gateway in the public internet. Then the private subnet will request some will send his request to the public one. Then through this NAT gateway, the public will address to the public internet. Then the private subnet can download patches or anything through this NAT gateway. Basically, to make this possible, there is a method called network address translation. So basically, the point is you will put a service called NAT gateway in the public subnet. Then through this service, the private subnet or resources in the private subnet can have access to the internet. So your database can download patches from the internet securely. So we have talked about subnets. So let's get back to the VPC console. Then, as you can see, we have given a name for our VPC. Then we have specified the CIDR block for our VPC. Then, as you can see in the preview part, there are four subnets. The first two subnets are in the US East 1 availability zone. The second ones, these two subnets are in the US East 1B availability zones. So let's change that. Let's make one availability zone. So we only want our VPC in one availability zone. So as you can see, we only have one public subnet and one private subnet. So uh, for example, here we are using the VPC and more way of creating VPC method. But if you choose this the VPC only method, you will specify a name, you will specify the CI data block, then you will create the VPC. After that, you will configure, you will create the subnets, you will create the internet gateway. After that, you will attach the internet gateway to the VPC. You will configure all of the detail by yourself. But we will follow this method. Basically, you will just, all you have to do is you will just give it a name. For example, let's give it a name of, for our VPC, let's give it a name of web. Then the CIDR block should be as it is. After that, we will change the availability zone to one, and one public subnet and one private subnets. As you can see here, you can customize the public subnets. So here, the whole VPC have access to 65,000 IP addresses. Then as you can see, when we divide, we have given 4,000 IP addresses to the public subnets, and we have given 4,000 another IP addresses to the private subnet. For example, if I change this to 24, sorry, to 24, I only have 256 IP addresses are available for the public one. So you can customize it uh, as you want. And the other thing I want to tell you is you can explore the internet about subnetting or about segmenting or about classifying uh, networks into subnets. So here we are not uh, talking about subnetting in depth. So basically, so this is not a 2 or a 3 hour tutorial, so we will not talk about subnetting in depth. So basically, you will just uh, specify the subnets. After that, we don't want S3 gateway. Basically, S3 gateways endpoints can help to reduce NAT gateway charges and improve security by accessing S3 directly from the VPC. Basically, we will use S3 gateway to get access to the S3 service directly from our VPC. So we don't want that, none. So if I leave S3 as it is, here in the preview, you will see web VPC S3. So we don't want that. We will change it to none. Then as you can see, we have web VPC. Yeah, web VPC. Then we have two subnets. Here we have configured it here, the subnets. Then as you can see, there is a route table. So what is route table? Let's talk about that. So basically, a route table in AWS VPC is like a map that tells the traffic where to go. So it defines the paths that data flows to reach the destination. So without proper routing, data can't travel between your subnets or out to the internet or to the public internet. So basically, route tables control traffic flows. For example, they will tell traffic how to travel within your VPC. For example, if you want an EC2 instance to talk the internet, the route table tells it how to get there. For example, through the internet gateway, as you can see here. And there is also uh, private and the public subnet. So different subnets in your VPC can have different route tables. So the public subnets, for example, usually route traffic to an internet gateway, and the private subnets route traffic through the NAT gateway. So we will handle all this using the route table. And the other thing is associating subnets with the route table. As you can see, for example, here, the public subnet is associated with the web route table public. Then this web route table public is associated with what? The internet gateway. So basically, this public subnet, this public subnet through the route table, through the public route table, will have access to the internet. Because of what? This route table is associated with what? With the internet gateway. As we have said earlier, if the private subnet wanted to have access to the internet, they will use the NAT gateway. If the public subnets want to have a direct internet access to the internet or to the public internet, they will use the internet gateway. As you can see from the flow, here there is the VPC, the whole VPC, and in the VPC we have two subnets, the public and the private one. Then the private one is associated with the private route table. Here the RATB abbreviation is basically route table. So this private subnet is associated with what? With the private route table. Then the public subnet one is associated with the public route table. Then the public route table was associated with what? With the internet gateway. And this internet gateway will give an access to the internet to what? To this public subnet. So basically, route tables in the VPC controls the traffic flow. So I think I believe this is clear. So basically, public route tables route traffic to the internet gateway. The private route tables route traffic to the NAT gateway. So after creating this custom VPC, we will see this uh, in practice. So I think we have uh, successfully uh, filled all the required thing in the VPC. So let's create the VPC. So as you can see here, it's creating the VPC. Then here it's creating subnets. Then it will create an internet gateway. Then it will attach the internet gateway to the VPC. So this VPC will have will have an internet access. Then it will create a route table. After creating a route table, it will associate with the subnets. Then, as you can see, we can view our VPC. So now let's check our VPC a little bit. So as you can see, our VPC is named web VPC. Sorry, it's CIDR. We can see it here as we have specified here the CIDR. And let's go to the subnets. As you can see, we have two subnets. The first one is web subnet public one, US East one. The second one is private one. Let's see the public one. As you can see here, the public one flow log. Okay, no flow log, route table. As you can see here, this uh, this public subnet have two routes. So let's see it. As you can see, if I click the, okay, we don't need that. As you can see, this public subnet through the internet gateway. As you can see, it says IGW. Basically, it's an internet gateway. Through this internet gateway, it have an internet access. As you can see, 0, 0, 0, 0. Basically, what this means is this public subnet can have an internet can have an interaction with the whole internet. With what? Through what? Through the internet gateway. So basically, this route table is defining the traffic flow. Now let's see the private one. As you can see, if we look at the private public subnet route table, it only have what? Local uh, local flow. Basically, this private subnet only access only can only request can only send a request inside the VPC. So let's here in the actions, I believe we can edit the subnet settings. Okay, not here, but I believe we can change this in the route table. So here the private one, let's get into that. After that here, let's edit. So let's add a route through the whole internet basically. And here let's say NAT gateway. So because we give an internet access to the private subnet through what? Through NAT gateway. As you can see, we didn't create an NAT gateway. So first we have to create NAT gateway. Where is that? Where is that? NAT gateway, NAT gateway, sorry. NAT here. Here NAT gateway. Create a NAT gateway. Let's give it NAT, let's say it NAT subnet. We will put our NAT gateway in what? In the public subnet. Then we will allocate an elastic IP. After that, we will create the NAT gateway. Then let's go to the VPC. Let's get into it. Actions. Sorry, let's go to the route table. Then let's edit the routes. So now we can give an internet access to our private subnet through what? Through the NAT gateway. We have deployed or we have putted the NAT gateway in our what? In our public subnet. So now let's save changes. So as you can see in the route table, we have this private subnet have access to the whole internet through what? Through this NAT gateway. This NAT gateway is deployed in what? In the public subnets. As you can see here, there is an internet gateway. This internet gateway is attached to what? To our VPC, as you can see here. So I think it's clear about our VPC. Let's see our created VPC in diagram. Okay, now let's make it clear a little bit the thing we have been talking about the whole video through diagram. So first, when we started creating our custom VPC, we have created the VPC that was obvious. We have specified this is the CIDR. So after creating our VPC, our whole VPC, then we have segmented it or we have divided it into two subnets. What? Public and private subnets. So for the public subnet to have access, to have a direct access to the internet, we have to he have to go through what? Through the internet gateway. When we create these two subnets, when we create them, explicitly they are not public, even though we gave them public and private until uh, until we specify it by doing some things like, for example, if I attach an internet gateway to this public subnets. Basically, to this subnet, basically, I am saying this is the public subnet. But if only the name that if only if I specify, for example, public, and then there isn't anything associated with the internet gateway with these subnets, this is not a public subnet. It is just the name. So we have divided the CIDR saying public and private. Then after that, we have created an internet gateway. After creating the internet gateway, we have attached this internet gateway with what? With this VPC. So after that, we have to specify the traffic flow using what? Route table. So for the public route table, we will give access to the whole internet through what? Through internet gateway. So through this internet gateway, this public subnet will have access what? Direct internet access to the public internet. Then for the private one, we will create a private route table. This private route table will have, or this private subnet will have an internet access to the whole internet through what? Through NAT gateway. This NAT gateway is deployed in what? In this public subnet. So here there is a, sorry, there is a private route table. This private route table, this rule is associated with what? With the private subnet. So let's elaborate this point a little bit. So we have created a route table saying that through the internet gateway, we can what? We can have a direct access to the whole internet. Then after creating this route table, we will associate it with what? With the public internet, because this rule is more related to the property of what? Public subnet. Here we will specify a route rule, which is private route rule. Through this NAT gateway, we will give access, we will get access to the whole internet. This is more related to what? To the private subnet. So we will associate this route table with what? With the private subnet. So the public subnets have a direct access through through the internet gateway, but the private subnets have some sort of internet access through what? Indirect internet access through what? Through NAT gateway. So first, it will send his request to the public subnet. After the request is in the public subnet through NAT gateway, it will get to the public internet. Then the response will get back to the what? Not directly to the private subnet, but to the public. After that, to the private. So I believe the flow is clear. So we have created a custom VPC successfully. So even though I didn't tell you that I have started doing the first hands-on, so we have done the first hands-on part. So we have created the first custom VPC. Then let's deploy a simple static web server or a simple static website in this VPC. So to do that, we have to create what? We have to launch an EC2 instance. So let's go to the EC2 management console. Here, as you can see, I am in my EC2 dashboard. Let's go to the EC2 instances page and let's launch an instance. Here, let's give a name for our instance. Let's say web. Then let's choose an Amazon machine image. I will stick with the Amazon Linux machine image. Then I will also leave as I will choose the T2 micro one because it's a filter eligible. for the key pair part, since we want access this virtual machine from remote area or through SSH, we will proceed without a key pair. Then we have to edit what? The networking setting. So let's do this. So as you can see, for the VPC, we want to deploy our web server in what? In our custom VPC, which is web VPC. And since this is a user facing server, a user facing server or a user facing application, we will choose which one? The public one. But if we are launching a database instance, the choice will be what? The private one. So we will choose the public one. We will enable the auto assign public IP, and if there is an existing, so let's create a security group. Basically, security group is a set of firewall rules that control the traffic for your instance. So since we are creating a web server, we have to allow an HTTP request to our instance. So let's give it a name. Let's give a name for our security group. Let's give it web SG. Then here, the type of protocol that we are allowing to our instance is HTTP. Then from what? From anywhere. And the final thing is, so after specifying the security group, the final step will be providing the user data for the web server. So here, as you can see, I have generated a user data script for uh, so you can use this prompt, generate a user data, to see a simple static website in Amazon EC2 instance. So here I will paste the user data, then I will launch my instance. Basically, this instance is launching, or this instance is this instances have been created in our custom VPC. Let's go to the instance, yeah, here. So it will take time, it will take a couple of minutes until it's ready, so you have to be patient. So as you can see here, it's saying initializing. So for example, for the networking part, we can see the retail. As you can see, the VPCs, web VPC. So this is EC2 instances deployed in our custom VPC. For the subnet part, it's deployed, or we have put it. I'm not sure that was a right vocabulary, but we have put it in the public subnet. And the availability zone is US East 1A. What was the other thing? Okay, security. For the security, we have allowed HTTP requests to our instance. Details here. So let's refresh it if it's ready. Still initializing. So now, as you can see, the instance is ready. So we can check the web server. So let's click in the instance. So we will use this public IPv4 address to have access to our web server. So I just click here the open address button. You can also copy the IP address and paste it in the, I don't know what, just you can copy it in your browser. So here it's loading. Since we only give an access to HTTP protocol, so we have to uh, exclude the S, or we have to change it to HTTP. Now let's click it. As you can see, welcome to your static website. This static site is hosted on an Amazon EC2 instance. So in this episode, we have created a custom VPC. Then we have hosted our simple EC2 instance web server, in that custom VPC. I know. So don't be disappointed. I know this episode is not good enough. So I didn't explain what internet gateways in depth, what's not gateways in depth, what network address translation is, what subnetting is. A lot of concepts I didn't uh, explain in depth. But if I try to do that, this video will take 3, 4, even 5 hours to explain all these concepts and other additional concepts. For example, I didn't explain enough about route tables and route table associations. I know that, but if I try that, it will take a lot of time. So in this session, I just wanted to give you an oversight to the AWS VPC. So I wanna show you how to create an AWS VPC in an easy way. So that's all. Maybe in the future I will create a series on AWS VPC. So I think this is enough for this episode. So thank you for watching. Don't forget to subscribe and like this video, Grace Academy. In the next episode, we will talk about Amazon RDS or Amazon Relational Database. Yeah, I think that was my plan. After that, we will deal with AWS Lambda. So, thank you. Grace Academy.